Let's go through certain basics. So at level 1 we had a introduction to swap contracts. What we said here at level 1 simply is that there are two parties with a notional amount of assets with different return metrics, and then they decide that they want to exchange those returns with each other. So we saw a very popular type of swap at level 1, which was called a plain vanilla swap. So what is a plain vanilla? Let's say there are two parties. The first one here agrees that for next 5 years, irrespective of what happens in the market, I will pay you a fixed 10% return on a notional amount of, let us say, 1 million. The other party says that for next 5 years, irrespective of what happens, I would pay you a variable rate, let's say LIBOR, plus an additional spread of, let us say, 2%. So one party paying fixed, other party paying variable. At level 2, we are going to say that this party is going to be a fixed rate payer, and this party is going to be a fixed rate receiver. That means we are denoting them in terms of who pays fixed and who receives fixed. The denotation is happening in terms of fixed rate. So if I simply tell you payer swap, a payer swap, that means the one who is on the fixed rate payment side. If I say a receiver swap, that means one who is receiving the fixed rate. This is the basic. Now let's think from the fixed rate payer perspective, what's happening to him. So fixed rate payer, he's got a notional amount of 1 million. For next 5 years, each of the year he's going to pay 10% on this amount, and what he is going to receive is some floating rate plus some additional spread of 2%. So LIBOR plus 2%. Now what we are going to do is that these cash flows we would try to replicate using a combination of fixed rate and floating rate bond. The same cash flows that we have in this swap, we will try to replicate using a fixed rate and a floating rate bond. So can I say that every year when I am paying 10%, that means in a way I have issued a fixed rate bond? Is that correct? So the only difference is I am not paying the face value at the end, isn't it? We don't pay that in swap, but except that everything else is being taken care of. So it appears like I am a fixed rate issuer. Fixed rate issuer can also be called as a short position on a fixed rate bond. Same thing. Shorting means issuing. So either I am saying I am a fixed rate issuer, or I have a short position on a fixed rate bond. Every year I am receiving L plus 2, LIBOR plus 2%. Can I say that this is nothing but being long on a floating rate bond? Correct? Now what happens? That when I am long on a floating rate bond, do I expect to receive the notional amount at the end, the face value? Yes, I will receive the floating coupons. So for example, if I buy a bond, let's say for $1,000, for next 5 years I will receive L plus 2%. Then at the end of 5th year I will receive my 1,000 back. And here when I've issued fixed rate bond, I'm paying 10%. At the end of 5th year I will pay 1,000 back. So that 1,000 is now nullified, isn't it? So which means that now we can compare a fixed rate pair swap is equal to being long on a floating rate bond and short on a fixed coupon bond. Because so now I have a two portfolios. Number one portfolio is I am a fixed rate pair in a swap. The second portfolio is I take short position on a fixed coupon bond and I take long position on a floating coupon bond. So, and then the value of this portfolio, let's say portfolio 1, and the value of portfolio 2 should be exactly same because their cash flows are same. Do you want me to repeat this again? Okay. I thought you'd say no. See what I mean here is, may I clear off the screen? देखो बहुत simplistic. Let's say a 3-year period. 1, 2, 3. What am I as of now? As of now, I am a fixed rate pair in a bond. Let's say, what is the fixed rate pair swap? What is the notional value? Let us say notional value is $1,000. What is the fixed rate? Let us say 10%. What is the floating rate? LIBOR. The life of the bond, let's say 3 years. What's happening? This is where I pay 10%. Then I will pay 10%. I will pay 10%. What will I receive? I will receive what was the LIBOR on that particular day. I mean, of course, a period earlier, but LIBOR, then LIBOR here, and I will LIBOR here. So let me call this as LIBOR 1, LIBOR 2, LIBOR 3. These are my cash flows when I am in a fixed rate pair swap. What I also do now simultaneously, I build a portfolio. Okay, what do I have in my portfolio? I take a long position on a variable coupon bond. Okay, so instead of floating, I'm using the word variable. I'm taking a long position on a variable coupon bond and a short position on fixed coupon bond. Meaning of a short position on a fixed coupon bond means that I am a issuer. I have issued the bond, I have received the money. So now what will happen? My short position on a bond will require me to pay 10%, 10%, 10% and 1000. So this is what I'm paying. So in fact, let me make this negative. Let me also make this negative because I was paying that. So 10%, 10%, 10% plus I have to pay back the principal amount. I am simultaneously long on a variable coupon bond. So on this side, long on variable coupon bond. What's happening here? I will receive L1, receive LIBOR 2. I will also receive LIBOR 3, and I will also receive my 1000 back at the end. Now, are those 1000 getting nullified here? So effectively, if these thousands are getting nullified here, can I not say that two cash flows are exactly same? Correct? And therefore we can conclude that if you are in a fixed rate pair swap, it is equal to being long on a variable coupon bond and being short on a fixed rate coupon bond. Clear? So now you can write this down quickly.
The last cash flow is getting nullified, but the intermediate are not.
You don't want this to be nullified with this. What you want is that the cash flow that you have here is exactly same as what cash flow you will have here. And as long as they're same, we are okay. That's what we are trying to prove. Do you want me to repeat this again, Nitin?
And depending upon what's the value of L,
Mm-hmm.
that would determine who pays.
Yes, that would determine who pays who. That's correct. So at this stage, the whole purpose of this calculation is to prove that being a fixed rate pair in a swap is nothing but being equal to having two bonds in your portfolio. On first bond, a short position. On the second bond, a long position. So if you have two portfolios simultaneously, both of them will fetch you the same value. Is it clear? I am not confident about you. जितन आया समझ में ये? Back there, Komal. Saurabh, ठीक है? Alright, let's see the other way around now. So this is a fixed rate pair. Let us say, I'm clearing off the screen. Now you are a fixed rate receiver. You are in a fixed rate receiver swap. Let's say again, notional amount 1000. Let us say fixed rate is again 10%. Floating rate, let's say simply LIBOR. Life is, let us say, 3 years. So what will happen? When you enter into swap, when you buy the swap, how much premium do you pay? Based on the rate at it's available? There's no premium, isn't it? Swap is a OTC contract. So generally there is no premium unless and until that term of the agreement says that you have to pay. Generally swaps wouldn't have any premium. So my cash flows at inception are 0 and 0. But what do I have to pay over the period of 3 years? Year 1, year 2, year 3. My floating rate is LIBOR. So can I say that I have to pay these different LIBOR rates? So let me again make them negative. Minus L, minus L2, minus L3. Why I am using L1, L2, L3? These rates would be different. No, these are floating rates, so not necessarily they would be same. What will I receive? I will receive a fixed 10% for each of the year. And these are my cash flows on this particular type of swap. Are we clear? Now instead of this, let us say that I somehow am not lucky enough to find a counterparty to enter into a swap. So I decide that I'm going to replicate the cash flow by taking two opposite positions on two bonds. So what now? I will take a long position on a fixed rate bond. Long position on a fixed rate bond, let's say, which has got coupon of 10%. And I will take short position on a floating rate bond. A short position simply means you are issuing the bond. Issuer. So now what happens? This is time 0. In fact, in the earlier calculation we missed this. When I take a long position, I will have to shell out 1000. Correct? When I am buying the bond, I will have to pay that amount to buy the bond. But when I am issuing the bond, again I will receive 1000. So here again those cash flows are nullified. So again it doesn't have any significance. Now what do I have to pay? Since I have issued a floating rate bond, year 1, 2, 3, I have to pay whatever was the rate in the market. But what do I receive? Each of the year I receive 10% because I am long on the fixed rate bond. Then here again I pay 1000, I receive 1000, that 1000 gets nullified. So again what cash flows I have in these two combination of bonds is exactly same as what cash flows I had in the swap. Are we clear here? Are you done writing this? Okay. So let's make a quick flowchart so that it will help you remember later on. FC I'm going to say is fixed coupon bond. And let's say VC is a variable coupon, so that there won't be any confusion. So now swaps, either you are a pair swap or you are a receiver swap. When I say pair swap, it means I will pay fixed rate and receive floating or receive variable. Receiver swap means I will pay variable coupon and I will receive fixed. These cash flows can be replicated using the following two combination. And then how do you remember this? Very straightforward. Whatever you receive, you are long on that. Whatever you pay, you are short on that. So here, what am I receiving? Variable coupon. Am I receiving variable coupon here? So I am long on a variable coupon bond. And I am paying fixed coupon. So here, I am short on a fixed coupon bond. Again here, what I am receiving? I am receiving fixed. So I am long on a fixed coupon bond and I am short on a variable coupon bond. So I don't think that this is something that you need to remember. I think once you solve a couple of questions, this will start coming to you automatically. Any questions here? Clear? Okay. So what we want to derive is some formula today. This was a step 1 of that formula. Okay, so this is done. Now step 2, we need to prove something that we had done at level 1 as well. That value of a variable coupon bond, that means a floating rate bond, is always equal to par value on reset date. Do you remember this? That a variable coupon bond, a floating rate bond, will always trade at its par value on each of the reset date. So we'll do an example to understand this. Okay, let's say we have a simple 4-year bond, which is a floating rate bond. This is time 0, this is 1, this is 2, this is 3, this is 4. Now, how do you value a bond? Value of bond at any point of time is present value of future cash flow. The problem here is I do not know what are going to be my cash flows, isn't it? Because my cash flows is going to be, let's say, based on LIBOR, and we know that LIBOR will keep on changing. So how do I know at time 0 what are going to be my cash flows here? Therefore I cannot value it easily. But now let's do it the other way around. Let's say I am at time 3. Okay, I have reached here. Do I definitely know that I'm going to receive my face value back? 1000? Yes. Now let us say LIBOR here is 8% and LIBOR here is 10%. What is the rate at which you would be paid coupon at the end of year 4? 8%. That the coupon is paid for a 1 period earlier rate. The idea behind this is that for this period 8% existed, 10% would exist for the next period. So I know that next period my coupon is going to be 80. Correct? So if I decide to value the bond at the end of year 3, what are the cash flows do I have? 1080. What is the rate is in the market? 8%. So how do I value 1080 discounted at the rate of 8% for 1 year? How much is that? 1000. So the value of bond in the market at the end of year 3 is going to be 1000. Let's say this is not 8, this is 12. Then how much would be this cash flow? 120. So 1120 discounted at the rate of 12%. What is the value? 1000 again. Which means now I can definitely conclude that irrespective of what happens at the end of year 3, the market price of the bond is going to be exactly equal to its par value. Proved? Yes or no? So once I know that at the end of year 3 market price is going to be 1000. So if I decide that no, I want to sell the bond at year 2 itself, what cash flows will I have at the end of for the next 2 years? So I anyways know that I can sell the bond at the end of year 3 at 1000. Plus I will also receive a coupon. But now this coupon would be based on what rate I have at year 2. So year 2 6% rate hai. If the year 2 rate is 6%, then I will receive 60. 1060 discounted at the rate of 6%. Again the bond value would come out to be 1000. If this is 12%, 1120 discounted at the rate of 12%, again it would come out to be 1000. So which means the bond value is 1000. And if this is 1000, again we can prove that this is 1000. And if this is 1000, again we can prove that this is 1000. Hence proved that a variable coupon bond would always trade at its par value on reset dates, not necessary in between. So in between it might fluctuate, but on reset date it would always be same. Is it clear? Another way of thinking of this is, which bond trades at par value? Those bonds which give you coupon at par with market rates. And variable bond every year does that. It always gives you the rate what is there in the market. Therefore on reset date it will always be at par value. Is that clear? So now in step number 1 we prove that a swap portfolio can be replicated using 2 bonds, one long and one short. In step number 2, we proved that a variable coupon bond on a reset date is always trading at its face value. Now we want to use the 2. And then what do we want to do together using the 2? At level 1, you had calculations like these. They said that there is a swap which has got fixed rate of 8%, face value or notional amount of 1000, and variable rate turned out to be 12%, who's benefited. Right? Child's calculation, that you took out the difference, multiplied with notional value, you got profit or loss. But you never really questioned that how did they price that swap, isn't it? How did that get that fixed rate? So at level 2, you get to study that how is that 8% derived. Okay, now just a little bit of basic. Let us say we have a bond which has got cash flows like this: 100, 100, 100 and 1000. That means a coupon of 100, 100, 100, a face value of 1000. You want to value the bond today. Let us assume discounted in the market is 12%. Okay, so value of the bond today is equal to 100 divided by 1 plus 12% raised to 1. 100 divided by 1 plus 12% raised to 2. 100 divided by 1 plus 12% raised to 3. And 1000 divided by 1 plus 12% raised to 3 again. Now instead of saying 1 plus 12% raised to 1, instead of dividing by this, I can directly multiply with something called as a discount factor. Okay, so how? Simply on your calculator, let's do it together. 1.12, which is nothing but 1 plus 12%, 1.12 inverse 1 by x. So 100 into 0.89. Okay. Then plus 100 into 1.12 x square and then 1 by x button. First take the square and then say 1 by x. 0.79. Then 1.12 x square into 1.12 and then take a inverse. 0.71 and then 1000 into 0.71 again. So these 0.89, 0.7, 7971, these are called discount factors, and these discount factors today I'm going to call them as Z. So to this number I'm going to say Z1, to this number Z2, this number Z3, and this number Z3 again. So Z is nothing but the discount factor for the appropriate time period. Are we clear here? Okay. So let us start the calculations now. We want to price, not value, we want to price now a fixed rate swap. We want to price a fixed rate swap. Fixed rate swap, let's say from the pair perspective now. So from a pair perspective, what do we know? That if you are a pair, you're long on a floating rate bond and you're short on, इसको floating की जगह पे variable, a variable rate bond, and you're short on a fixed rate bond. Now if this is the case, now think of it logically. Is it possible that this bond would trade at 1000 whereas this bond is trading at 900? What I mean to say is, when you're entering into a swap, it's equal to entering into two bonds parallelly, one long, one short. Do you think it's possible in the market that the one bond is trading at 1000, other is trading at 900? If this is the case, then isn't that a clear arbitrage? because a swap is equal to these two, correct? But if you do these two, you're left with positive 100. So you can easily exploit arbitrage. So at inception, why would someone enter into a swap if he's losing money or winning money? Of course, he would want to enter if he's winning money, but the other person is losing money. So he would not. So what I mean to say is, when you enter into the swap at time 0, the value of this fixed rate bond and floating rate bond has to be same. So the value to the swap originator is 0. Otherwise, then they would not enter into the swap at all. समझ में आ रहा है? Should I repeat again? देखो, when you are entering into fixed rate swap, it's same as buying a bond and selling a bond, correct? It's same like getting these two portfolios together, getting one asset of 1000 and one liability of, let's say in this case, 900. Think from the person who is on the other side. For him, whatever asset you have, for him it's a liability. And whatever liability you have, for him it's a asset. So why would he enter into a swap like this when at time 0 when he signs the swap, immediately he loses 100? No, he would never do that. Which means this kind of a scenario is not possible. So when you enter into a swap, both of them have to be 1000. So which means at time 0, when the swap is being entered, that time the value of fixed rate bond and value of floating rate bond has to be equal. Agreed? So now let's mix everything together. We want to price the swap. Pricing the swap means finding out fixed rate.
So when you say value has to be equal, then essentially you are referring to the yield to be
No, the value of the bond. Market value, yes, market value. See, it's like someone comes to you and says that parallelly I'll give you one asset of 1000, one liability of 1000. Are you okay? You might be okay. But if someone comes and says I'll give you asset of 1000, liability of 1100, will you take it? No. And will someone come and say I'll give you asset of 1000 and liability of 900? He will not do that. So the only case in which swap will happen if both of them are 1000. That means the value of fixed rate bond and floating rate bond is same. So that fixed rate cash flow, I am going to call that as C now. Have we also proved that floating rate bond at inception, that means at time 0, is equal to its face value? I'm going to call that face value as 1. Okay, so let's first price the fixed rate bond. How do you decide the price of fixed rate bond? Let's assume that there are 4 cash flows. So C plus C plus C plus C. 4 cash flows and they are going to be same. Just in our example, 1000 is the face value, 100, 100, 100, 100. So C, 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 C. Correct? Into, I have assumed that my future face value is 1. So into 1. Sorry, plus 1. And now we are going to discount them. So multiplied with Z1, multiplied with Z2, multiplied with Z3, multiplied with Z4, multiplied with Z4 again. So first coupon discounted for 1 year, second coupon discounted for 2 year, 3 year, 4 year. Principal, which is 1 rupee, is discounted again backwards for 4 years. Are we clear? This is the value of fixed coupon bond or fixed rate bond. And we know that this value should be equal to floating coupon bond. And what we also know is that floating coupon bond at time 0 will trade at its face value, which is 1. So 1 is equal to this equation, 4 coupons multiplied with their respective discount factors and the last discount factor. Now let's solve for this. 1 is equal to C, I'm taking this common, Z1 plus Z2 plus Z3 plus Z4 plus this is Z4. So C is equal to 1 minus Z4 divided by Z1 plus Z2 plus Z3 plus Z4. So this is the formula that we are going to use to calculate what should be the fixed rate or fixed amount of coupon or the fixed rate of coupon that should be given on that bond so that the value of that swap is 0 at inception. Are you done writing this? Let's repeat the whole story again one more time. Let me clear this off. Okay, write it quickly, please. Okay, now this derivation is not required for exams, but then in case if you forget the formula, you can still derive it. It's a very, very simple derivation, just 2-step. Okay, let's repeat the whole story again. I'm deleting this now. First, what we said, that a swap is equal to a simultaneous position of two bonds. So at times you're long on a fixed rate bond and then plus short on a variable coupon bond or vice versa. So we proved that this is always true. Then second thing that we said, that a variable coupon bond on every reset date including the time 0 will always trade at face value, let's say, which is 1, which was the step 2. Is that correct? Step 3, that when someone is entering into a swap where he simultaneously get one asset and one liability, he will never enter if the asset value is smaller than liability. The other person wouldn't give him higher value as asset, which means in order to make sure that the value of swap at time 0 is 0, the value of fixed rate bond should be equal to value of variable coupon bond. Then in step 4, we know that value of variable coupon bond is nothing but 1. What is the value of fixed coupon bond? All the coupons plus the face value of 1 discounted backwards. So when we are discounting them backwards, instead of using the discount rate, we are simply multiplying them with discount factors. So 1 is equal to C into Z1 plus C into Z2 plus C into Z3 plus C into Z4 plus 1 into Z4. And then we just solve this equation and find out what would be Z. We take the C common first. So 1 is equal to C Z1 plus Z2 plus Z3 plus Z4 plus Z4. Z4 shifts here and this goes in the denominator. So C is equal to 1 minus Z4 divided by Z1 plus 2 plus 3 plus 4. This is how that fixed coupon is derived, so that value of fixed coupon bond and floating coupon bond is same, so that value of swap at inception is 0 to both the parties. Sorry, can you ask your question again? Okay, good question. He says, what if I want to have swap in between the reset date? Whenever your swap starts, that's the reset date. That's the answer. Because this is not a true bond, this is a hypothetical bond that you've created, isn't it? So the day your swap starts, that is the day on which the variable coupon bond is born. So the reset date would always be the same. There are different LIBORs, yeah, but LIBOR is reshuffled every day, yes. Variable coupon bond, yes. And these are hypothetical bonds, these are not real bonds. We've just used that analogy so that we can derive this formula, and now we know that how to find out a fixed coupon rate or a fixed rate in a swap. So we have now understood how to price a swap. Any questions you want to ask? Is it done? Clear? Let's assume that you haven't understood much in the last 30-40 minutes. What you need to know out of all this is this formula, which you can mug up. C is equal to 1 minus Z4 divided by Z1 plus 2 plus 3 plus 4, and you need to know this. Okay, for few of the theory question where there's a case study and one analyst says that ऐसे होता है, the analyst says the other way around, and then which one of them is correct? One is correct, two is correct, both of them is correct. You should know that the one who says this is correct. Okay, so if you know these two things, we are through with this part of the calculation. Yeah, here your 4 coupons. If we have 5, then it gives 1 minus Z5 divided by 4 discount factors. If you have only 3 coupons, 1 minus Z3 divided by 3 discount factors. Are we clear?